Hey everybody, it's Mr. N here, and we are doing our next lesson. This is on similar polygons, and let's go ahead and get started. You already know that we have this symbol that we use for similar. It's this little squiggly, and this one with the equal sign is congruent. So congruent means all sides, all angles are the same exact measure, but similar means that they are in proportion. So figures that are similar are figures that they have the same shape, but not necessarily the same size. Now they can, we'd say it's a one-to-one similarity, but typically it's going to be either larger or smaller. So here, these two are not similar because look at the size and the shape are not the same. So this, even though the sizes are different, the shapes are not the same, so we can't say they're similar. These two are similar. So when we have similar polygons, they're similar if and only if their vertices can be paired so that corresponding angles are congruent and corresponding sides are in proportion. So over here we have ABC and DEF, and we can say if these are similar, then I could say side B right here, this is a multiple of side B. So this would be K times B. So CA and FD are related because this is a multiple of it. And that's our similarity transformation. The angles will still stay congruent, but the sides will be in proportion. And then that proportion we will call the scale factor or the similarity ratio. So we can have it as 1, 2, 3/4, etc. Over here, perimeters will still be similar. So what this is telling me right here is if I have these two similar shapes and similar polygons, then the perimeters will share that same exact similarity ratio as well. Moving on, area is a little bit different. For area, notice the units on area, it's squared. So the area will have a squared proportion. So if these two right here have a similarity proportion of A to B, right, then the area will have a proportion of A squared to B squared. So that's what the area would be. Okay, so then you can set up the ratios. Suppose this is a 1:2 type situation, and this had a length of 10 and this had a length of 20. Well, then the areas, and if you knew the sides would be 1:2, obviously, the areas would be 10:20 squared, which would be 1:2 squared, which would be a 1:4 ratio. That's how that would work. All right, let's go ahead and do some examples. As always, we're going to do the student journal ones in class. Let's take a look at these additional examples down here, and we will work on these. So let's slide this up and do some of these problems. For this first one, it says, find the scale factor of the similar polygons, then solve for x and y. All right, so the scale factor here, this is 3 right here, and this is 2, so let's clarify that. So the scale factor is going to be 2 to 8, right? That's our scale factor. And if I wanted to solve for y, I could just say 2 to 8 would equal 3 to y. So 2 to 8 would equal this 3 right here to y. All right, and we can cross multiply. At this point, 2y equals 24. Y is going to be 6. Now, some would say, wait. Shouldn't the scale factor be 8 to 2 for the scale factor? Well, I didn't indicate which is the new and which is the old. Typically, we would write the scale factor as new to old, right? So I could have said, yeah, this is the new one, this is the old one, and we would say, okay, this is 8 to 2, which is a scale factor of 4, right? So our scale factor here would be 4. I could have said that. I could have indicated this is the new one, and that's the old one, then in which case the scale factor is going to be 1 out of 4, 1/4. So it just depends which is the new one. Because remember, you're going to take something and multiply it. If I multiply it by 4, I'm going to get something larger, right? So in other words, if this was the new one and this was the old one, yeah, it would be larger, so the scale factor has to be 4. If I did it the other way, 1/4, right, this would end up being smaller. So then, yes, then this should have been the old one, and that should have been the new one. Okay, so it just varies depending on if I indicate which is the new figure and which is not. If it doesn't, well, then it's not wrong. You don't have anybody tell you if it is wrong or scale factor is wrong. It just depends on which is the new figure, which is the old figure. Okay, over here, triangle ABC is similar to triangle A prime, B prime, C prime, and their scale factor is 7 to 9. If the perimeter is 42, then of a triangle ABC, then find the perimeter of triangle A prime, B prime, C prime. Okay, so we know a scale factor, and we know that this one goes with, okay, so this is 7 to 9, the way they're indicating it, just the way it's written from 7 to 9. The scale factor goes this way, right? And if the perimeter of ABC is 42, then find the perimeter of A prime, B prime, C prime. So since our scale factor is 7 to 9, we are going to set this up and say ABC is 42. So I could say 42 to the new perimeter is going to be the 7 to 9 ratio. Now, why did I set it up that way? Because when I read this, I'm assuming that this is A to B, right? So this 7 corresponds to the A and the 9 corresponds to the B. This perimeter, this is A to B, just like that. So that's why I set this problem up that way. And now we can go ahead and cross multiply, and I get 7x equals 42 times 9, which would be 378. So x would be 54. Okay, so typically we read it A to B. That's how I read this particular problem. All right, for the next one, we've got quadrilateral here, PQRS and quadrilateral TV. One side has a length of 12, so one side of PQRS has a length of 12. The corresponding side has a length of 15, so we can say this is A, that's B. So if I set up my A to B ratio, that would be 12 to 15. And the perimeter of TUVW, which is the second one, is 35. Find the perimeter of the first one. So we'll set the 35 up here, and we'll call the perimeter of the first one right there x. So now we just have to cross multiply, and I get 15x equals 12 times 35, which is 420. So x would end up being, divide that by 15, you will get 28. And on to the last example over here. Okay, let's see what we got. Let's do this one. It says the perimeter of two similar polygons are 20 and 8, so we'll call this A to B, 20 to 28. One side of the smaller polygon has a length of 4, so since this is the smaller, we'll put that there. And the length of the corresponding side of the polygon, we'll call that x. So 20 to 4, 20 to 28, 4 to x, and let's go ahead and solve for x. So we'll cross multiply, so 20x equals the 28 times 4 comes out to be 112, and divide that by the 20, you'll get 5.6. All right. That was the last example, but we did not do any with an area. So let's do something that's similar to this with an area one. Suppose I had two similar polygons, and the area of the first one is 30. The area of the second polygon is 10. So this is a completely different example. And one side length here is 5, and the other side length, I don't know. I want to try to find the other side length, so we'll call that side length x. Remember, the side lengths would be A to B. So if I took my ratio A to B, this would be 5 to x. If I square A to B, that's how I get the area ratio. So that means I'd have to say 5 to x squared gives me the ratios of these areas, which would have been 30 to 10. So let's go ahead and do this problem now. So I will get 5 squared, which is 25, over x squared, equals 30 over 10. We cross multiply, we're going to get 30x squared equals 250. So x squared would be 250 divided by 30, which would be 8.3 repeating. And then I could take the square root of that, and I would get my x, which would be 2.89, and that would be the length of the corresponding side on the second one. So that's how you do it if you have an area that you are trying to figure out. All right, so thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.